Hi students, in this video we are going to solve problems related to the intersection of the line and plane. The question is, find the distance between the point with the position vector minus I cap minus 5j cap minus 10k cap and the point of intersection of the line x minus 2 by 3 is equal to y plus 1 divided by 4 is equal to z minus 2 divided by 12 with the plane x minus y plus z is equal to 5. So for what we need to do is we need to find out the distance with the position vector, distance between the point with the position vector minus I minus 5j cap minus 10k cap and another point. That point is given by some other information, that is that point is the point of intersection of the line x minus 2 by 3 is equal to y plus 1 by 4 is equal to z minus 2 divided by 12 and the plane x minus y plus z is equal to 5. So first we need to find out this point, that is the point of intersection of this straight line and the plane. After finding the coordinates of this point, we can find out the distance between this point and this point. That will be the final answer. So our first aim is to find out the coordinates of the intersection of the straight line and this plane. Already we learnt this technique in the previous video. First what we need to do is we need to find out the general coordinates of this point from which we can solve the answer. So what we do is first we will find out the general coordinates of the point on this straight line. So the coordinates of any point on the line x minus 2 by 3 is equal to y plus 1 divided by 4 is equal to z minus 2 divided by 12 is equal to r. Because these are fractions, it will give some value. We assume it as r, from which we need to find out general coordinates of any point. That is, general coordinates means it might be x, y, z, because x can take different value, y can take different value, z can take different value based on the value of r. So we have to calculate x from, we can say that x minus 2 divided by 3 is equal to r. If we simplify it, 3r plus 2 gives us x value. Similarly, y plus 1 divided by 4 can be equal to r. So 4r minus 1 will be equal to y coordinate value. Z minus 2 divided by 12 can be equal to r. So 12 into r plus 2 will give us the general z coordinates. If this coordinate lies on this plane, because the general point may be on the top of this line or here, and this general line, one of the point must lie on the plane. That is the general point, means that point lies on the straight line as well as it meets the plane. So that point must satisfy the plane equation. This is the general point which which can represent any point on the line. We are considering a point which lies on the plane, hence this point must satisfy the plane equation. So in place of x in the equation we are substituting 3r plus 2, in place of y we are substituting 4r minus 1, in place of z we are substituting 12r plus 2 and is equal to 5. When we simplify it, we get the r value as 0. When r value is equal to 0, what we get is the point of intersection of the line and the plane. Hence the coordinates are, when we substitute r value is equal to 0 here, x value is equal to 2, y value is equal to minus 1, z coordinate value is equal to 2. This is the point of intersection of this plane as well as this straight line. Now we need to find out the distance between this position vector and this. From this we can write the general coordinates of this point as minus 1, minus 5, minus 10. Hence distance between these 2 points is calculated using the distance formula. You know this formula very well. The simplification is giving the final answer as 13. Hence the distance between the point, this point and the point of this point and the point of intersection is 13 units. I hope you understand this problem. Now we move on to next question. Find the distance between the point P 1, minus 2, 3 from the plane x minus y plus z is equal to 5, measured parallel to the line whose direction cosines are proportional to 2, 3, minus 6. Normally, when we want to find out the distance between the point and the plane, means what we can do is we can find out the we can apply the distance formula and then we can calculate it, but here it cannot be applied because the distance should be measured along parallel to this direction cosine. I will tell you what it is. Normally when we want to find out the distance between the point and the plane means we will try to calculate the perpendicular distance from the point to the plane, but here we are not calculating perpendicular distance. The distance has to be measured which should be parallel to the line whose direction cosines are 2, 3, minus 6. So the line which is parallel to this means it will come like this. Now we need to find out the distance between P and Q. Hence what we need to do is we need to find out this coordinates of point Q and then write it. What we can do is here PQ can be considered as the straight line and this is the plane. The point of intersection of this straight line PQ and the plane gives us the distance between gives us the coordinates of Q from which we can apply distance formula between P and Q, then we find out. So we need to find out the point of intersection of the line PQ and the plane. First we must find out the line equation. The line passes through 1, minus 2, 3 whose direction ratio is parallel to 2, 3, minus 6 means parallel lines have the same direction ratio, so we can consider direction cosine or direction ratio of the line PQ is also 2, 3, minus 6 and the line PQ passes through 1, minus 2, 3. I wrote it here. Direction cosines of PQ are proportional to 2, 3, minus 6 and the line PQ passes through 1, minus 2, 3. Hence the equation of the straight line PQ can be written as x minus x1 divided by a is equal to y minus y1 divided by b is equal to z minus z1 by c. Direction cosine can also be considered as direction ratio. Using that we have written the straight line equation. Now we got the straight line equation. Now we need to apply the concept of point of intersection of the straight line PQ and the plane. So first we need to find out the general coordinates of this straight line, which is coordinate of Q can also be written as x minus 1 by 2 is equal to y plus 2 divided by 3 is equal to z minus 3 divided by minus 6 is equal to r, from which we can find out the general coordinate, that is x is equal to 2r plus 1, y is equal to 3r minus 2, z is equal to minus 6r plus 3. These are the general coordinates of this straight line. This point may also lie on the plane x minus y plus z is equal to 5. Hence it must satisfy the equation. Hence in place of x we can substitute 2r plus 1, in place of y we can substitute 3r minus 2, in place of z we can substitute minus r plus 3. When we simplify it we get the r value of 1 by 6. So when we substitute r value in this coordinate we will get the point of intersection of the straight line and the plane. So putting 1 by r in this expression we get the coordinate as 4 by 3, minus 3 by 2, 2. Hence required distances from this coordinate to this coordinate, points Q coordinate, we are applying the distance formula, that is square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So we get the final value as 7 by 6 units. I hope you understand these two problems clearly. In the next video we will start a new concept related to plane. Thank you students. Thanks for your cooperation.